Myself, Dr. Seema Garg from Arya College of Engineering and IT, Jaipur, presenting a video lecture on series solution in differential equation part 3. As we have discussed earlier, the methods of solution in series depends on the roots of identical equation, and on the basis of its root, it can be categorized in following three cases. Case 1, the roots of identical equation are different. Case 2, the roots of identical equation are equal. Case 3, the roots of identical equation are unequal, differing by an integer and making the coefficient in series infinite. In all three cases, case 1 and case 2 are already discussed in previous video lectures. Now we proceed to case 3. The procedure of solution of case 3 is as same as case 1 and case 2, but writing the complete solution is some different from case 1 and case 2. To understand the series solution for case 3, we take a problem given by equation number 1. First, we put y equals to x की power m in equation 1. Then dy by dx equals to mx की power m minus 1 d2y by dx square mm minus 1 x की power m minus 2. Substitute the value of y dy by dx and d2y by dx square in equation 1. We get this equation. And after solving the equation in ascending powers of x, we get the equation number 2. Again, we see that the powers of x is in ascending order and the coefficients of various powers of x, that is the terms containing the powers of m, factorize as much as possible. Now, we calculate the value of s, that is the difference of highest and lowest power of x. Here the highest power of x in equation 2 is m plus 2 and the lowest power of x in equation 2 is m. So the difference is m plus 2 minus m equals to 2. Let the series solution of given equation 1 be y equals to summation r equals to 0 to infinity ar x की power m plus r s. Here s equals to 2. So after substituting the value of s, we get the series solution given by equation number 3. Again, if equation 3 is the series solution of differential equation 1, then it satisfies the differential equation 1. So we calculate dy by dx and d2y by dx square. Here we see that summation r equals to 0 to infinity ar is independent from x. So we calculate the differentiation of x की power m plus 2r in calculating dy by dx and d2y by dx square, given by equation number 4 and equation number 5. Now substituting the values of y, dy by dx and d2y by dx square in equation 1, we get equation number 6. Equation number 6 can be also obtained by the shortcut method from the equation number 2, which we have calculated the value of s. We have taken two substitution in this question, that is y equal to x की power m and y equals to summation r equals to 0 to infinity ar x की power m plus 2r. In both the substitution, the main difference is the power of x, that is 1. In one substitution, the power is m, and in second substitution, the power of x is m plus 2r. So we have to replace m to m plus 2r in equation number 2. Again, summation r equals to 0 to infinity ar. The term is remaining same in y dy by dx and d2y by dx square. So we write summation r equals to 0 to infinity ar in equation 2, both the terms x की power in both the terms of x, powers of x. Now we find equation number 6. We check that the power of x is in ascending order. In first summation, the power of x is m plus 2r. In second summation, the power of x is m plus 2r plus 2, which is in increasing order. So, in the first summation, we separate the terms by putting r equals to 0. In first summation, we get a0 m plus 1 m minus 1 x की power m plus the summation remains from 1 to infinity and the term is written as this. Plus, in the next summation, if we want to change it from r equals to 1 to infinity, we replace r to r minus 1 as discussed earlier. Now, we calculate the terms and we find the equation, this equation. And we see that in both the terms of summation, the power of x is same, that is m plus 2r. So, we take the common term summation r equals to 1 to infinity and x की power m plus 2r in both the summation terms. Now we have the equation number 7. Equating the coefficient of lowest power of x, that is x की power m to 0, we get the coefficient is a0 m plus 1 m minus 1 equals to 0. Again we take a0 is not equals to 0 because it gives the 0 solution. So we have the two values of integral equation m1 and minus 1. This is known as roots of integral equation. We get the two different values of m. As in the case first. Again, equating the coefficient of x की power m plus 2r to 0, we get ar m plus 2r plus 1 m plus 2r minus 1 plus ar minus 1 equals to 0, where r equals to 1 to infinity. Now we find the value of ar upon ar minus 1, which is known as recurrence relation, given by equation number 8. Put r equals to 1 in equation 8, we get the value of a1 by a0, given by equation number 9. Put r equals to 2 in equation 8, we get the value of a2 by a1. But we have to calculate the value of a2 by a0, which is calculated by a2 by a1 into a1 by a0. After substituting the value of a2 by a1 and a1 by a0 from previous equations, we get the equation number 10. Similarly, if we find the value of a3 by a0, we have to calculate a3 by a2 into a2 by a0 and so on. Now again, the series solution is given by equation number 3. We expand the summation for various values of r. Put r equals to 0. In this summation, we get a0 x की power m plus sign. Put r equals to 1 in this summation value plus put r equals to 2 in this summation value and so on. We take the common term a0 x की power m and in the bracket we have 1 plus a1 by a0 x square plus a2 by a0 x की power 4 plus so on. So the series solution y is given by equation number 11. Substituting a1 by a0 and a2 by a0 from equation number 9 and equation number 10 to equation number 11, we get the value of y in terms of m, given by equation number 12. Now, we have two values of m, that is 1 and minus 1. And here we see that if we take m equals to minus 1, then the coefficients of powers of x is infinite. Coefficient of x square when putting m equals to minus 1 is infinite. Coefficient of x ki power 4 when putting m equal to minus 1, it becomes infinite. So when we put m equals to minus 1, the series solution becomes infinite. So it is the case number 3. To eliminate this factor m plus 1, which makes the coefficient infinite, we take a0 equals to d0 m plus 1, where d0 is not equals to 0. Again, if d0 equals to 0, then the solution is 0 solution. From equation number 12, when we put a0 equals to d0 m plus 1, we have equation number 13. Now, again differentiating equation number 13 with respect to m, we get del y upon del m. Here in equation number 13, we apply product rule for differentiation. Here is the term x ki power m. The differentiation of x ki power m is x ki power m log x, and the bracket term remains as it is, plus d0 x ki power m term as it is, and we take the differentiation of bracket term. The differentiation of m plus 1 is 1. Differentiation of 1 upon m plus 3 is minus 1 upon m plus 3 ka whole square, and we take it as product term 1 upon m plus 3 ka whole square into 1 upon m plus 5. First we differentiate 1 upon m plus 3 ka whole square. The differentiation is minus 2 upon m plus 3 ka whole cube and 1 upon m plus 5 as it is. Plus we take 1 upon m plus 3 ka whole square as it is, and the differentiation of minus 1 upon m plus 5 is minus 1 upon m plus 5 ka whole square, and x ki power 4 as it is. So the del y by del m is given by equation number 14. Now the first solution, series solution, is obtained by putting m equals to minus 1 in equation number 13. We get the series y given by equation number 15. The second series solution is obtained by again putting m equals to minus 1 in equation 14. We get del y by del m at m equals to minus 1. Say it is m2 given by, say it is y2 given by equation number 16. Therefore, the complete solution is given by y equals to c1 y1 plus c2 y2, where c1 and c2 are constants. Now the question arises here that what about the next root of identical equation, that is for m equals to 1. If we put m equals to 1 in equation number 13 or equation number 12, it gives the series y equals to this. That is a series of multiple of y1. y1 is obtained for m equal to minus 1. So we get any new series solution for m equals to 1. So either we have considered only from these two, that is for y at m equals to 1 or y at m equals to minus 1. Summary of the series solution is for all the three cases. Thank you.